Hey guys, welcome back to my channel. I'm doing the path sum problem here. So this problem is basically given a tree of a binary tree and an integer target sum. Return true if the tree has the root to leaf path such that adding up all the values along the path equals target sum. So here the target sum is 22, right? And the root to the leaf path. So we want to find the paths that reach the target. So 5, 4, 11, and 2 added up all together would give me 22. So the output should be true. You're not returning the path, you're returning if you get the path. Another example is a target sum which is 5. You can no way find a path to get 5, so it's false. So here what you need is you need to have like two things. One is like a stack where you're going to like put in all the nodes that you're traversing, and then um, another one which keeps track of the sum. So you're going to keep subtracting it from like the target sum, and then you're going to like check whether you're getting the sum eventually or not. If you're getting the sum, then you're gonna return true. If you don't get the sum, then it's gonna be false. So let's start the problem. In all three problems, you want to do this initial check as always, where if root is equal to null, then you return false. There's no path basically, so you're just gonna return false. So like I said earlier, you need like a stack. So this one is like tree node. That's the variable given here. Um, and it's not this braces, it's not parentheses, it's the greater than less than brackets. And then I'm gonna call this node stack. Okay, so this is the stack variable. And then I need a stack which is actually an integer, because I need to keep track of all the the sums that are coming, I mean the nodes sum values that are coming in. So sum stack, yeah, so this is the, sorry, it doesn't have this. I have completely forgotten about that, because in array list and all that you have that. Okay, so that's the thing. And then what you need to do is you need to add the root node here into the linked list, and then you want to subtract the sum from the root value, like the root value from the sum basically. So you're going to do this. So the target sum is the value here, target sum minus the root value. So basically what you're doing is you're removing the root value because you're always traversing towards it, and then you go inside the loop. So what do you have inside the loop? Basically, while the node stack is not empty, you keep like going towards the loop, and you're going to check if you have a path or not. Okay, so let me just focus on this area now. So this is very important. So here you have like a tree node which has like the current node that you're traversing. So that's gonna be the node stack, the popped value. So the top value that you pop is gonna be the current value. And then you have another variable called current sum, just like you're just going to like keep adding it basically. So that's gonna be the stack. Wait, not stack, the sum stack. So this one basically. So one for like the node and then one for the value itself. So you'd need one for the current one, right? So that's why you create other variables for it. And then you're gonna keep going left and right, and you're gonna keep checking. So that's the main idea. So you wanna go left and right until you like find the values. So I'll just execute this function, this loop, sorry, this condition. So this is like a check basically. If it's equal, then like we found some. This is like the final condition. I'll explain. So what you're doing here is you are checking if there's no node values in the left or there's no node values in the right. Okay, I've put this double times. I'm so sorry. In the left and right, and then if there's nothing, and you know you've found the sum basically. So in that case, you're going to return true. So there is a path. So this is like a final check sort of thing. Okay. Um, so check this out. So first you want to go completely left. So this particular condition is to go completely left until you've hit the null node, that basically go till the root, and then you're going to go towards the right until you hit the leaf node. Okay, so you need to do that. What do you do inside this matters. So you have this stack value, right? You're just going to add that current left value, current node left value into it, and then you are going to like subtract. So sum stack dot add of current minus, sorry, current sum minus the current node dot left dot val. So you're subtracting and adding it to the sum stack. You're gonna do the same thing for the right, so that's why I'm copy pasting it. It's exact same thing. So you're going to go left and right. Yeah, so that's the thing. So you're going to add it to the stack, and then you're going to subtract and add it to the sum stack, and do the same thing on the right. And once you're like completely done, you would have reached a point where um, you know you would have reached a point where it's the sum is equal to 0, and then there's a null value. If it's equal to 0, then in that case you can return true. If it's not, you simply have to return false. So if it doesn't satisfy this condition, then you return false. So this should work. Hoping there's no errors. Um, Identifier expected. Hold on. What did I do wrong? Oh, sorry. Hmm. Isn't it the target sum? I mean, that's the value of the subtract, right? I think I need to add here, right? That's the mistake. Yeah. Yeah, it works. So that's the problem, you guys. You can just check out the whole code. It's a long problem. Yes, I agree. Like it's a little bit confusing, but once you figured out the where you saw, like you proceed with the problem, it will be easy. Okay, that's it. Thanks for watching. Bye bye.